Would you prefer to, wollt ihr so? Oder wollt ihr die anderen? Ja? Außer wenn der Thomas gerade mit dem anderen weggelaufen ist.
Eigentlich.
Da ist eins, schau. Das ist halt das mit dem Ort. Ist das wurscht?
Mir ist egal.
So. Ja, super. Okay, dann ich noch das an. Hast du nur noch hinten reinstecken? Soll ich das öffnen?
So, gut.
Hast du schon eingeschaltet? Michael und Daniel.
Yeah, thanks for coming to our talk. We will talk about hacking in games. Originally we thought about talking about Meltdown and Spectre, but Michael said that's a stupid idea, we shouldn't do that here. So we will probably talk about hacking in games.
Exactly. So, then an introduction again. So my name is Michael Schwarz. I'm a PhD student here at the university. You can reach me on Twitter, via email. I'll also be here around.
Yeah, same for me. I'm not a student anymore, but actually I re-inscribed a studying program now, just for other reasons. Yeah, so we will talk about hacking. And hacking games is as old as the gaming industry, right? When we started building computer games, the first computer games, they were like immediately hacked. We called it trainers back then, right? Or maybe cheat programs. And what we did there was we modified the game in a way that we preferred. So we exploited insecure implementations in a way that allowed us to do something that the game originally was not intending to allow. And we can not only use that for cheating, but we can also use that for piracy, of course. We can run games that we usually would not be allowed to run. I still remember when I patched this copyright protection out of my Need for Speed copy because I didn't want to put the CD into the computer all the time. Really annoying.
But you still bought it, right?
Yes, of course. So, bugs in games can be even more devastating still today because they can subvert the security of the underlying hardware as well.
Yes, so let's talk about more about this piracy here.
You like that topic?
It's an interesting topic, and I guess many of you have been in contact at some point with piracy. I'm not going to ask who. So maybe for the others who have never had anything to do with piracy, a short definition here, what is piracy? So we have the unauthorized use or reproduction of another's work. We do that sometimes in software, a lot of synonyms for that, and yeah, so we now know what we are talking about, right?
Okay, and maybe we want to bring that in the context of gaming consoles because
that's especially interesting for piracy because we have gaming consoles which are usually closed systems. We cannot just run any software there like on a computer. We can't just download stuff and run it there, write our own programs there. So it's pretty closed there.
But I would like to do that sometimes.
Yeah, that would be really nice because usually we as hackers don't get any certified games that we can run or other applications there. And that's a good thing from the viewpoint of the device manufacturer, of the gaming industry, because then we don't have illegal copies. If we are not allowed to run anything other than licensed games. And not everybody likes that. So many hackers, console hackers, like to run their own games, like Daniel. And we have a certain term for that, it's called homebrew. And from there, from running your own homebrew applications to run pirated applications, it's just a small step. Because basically when you can execute code, you can run any code. The system doesn't care anymore. And then we can also patch our games, manipulate them, run our pirated games there, if you want to do that. But because piracy is not such a good name, just call it homebrew, and then it sounds nice and not evil anymore, and we are allowed to talk about that. So makes it better.
Running homebrew, right, is sort of like a cat and mouse game, because you have this security today in this on these systems, on these gaming consoles, and you want to find a bug and then exploit this bug and then run the code that you want to run. For instance, maybe I want to run my own operating system on a V. I can't do that without finding a bug and exploiting the bug. But then you get an update for the Wii console, and then you can't exploit this bug anymore, which is quite bad. Then I can't run my own operating system there anymore.
So you have to find another bug.
Yes. This also has a very good side, because while we do that, finding bugs, patching the bugs, the security of the system gets better and better. So we get more and more security in those systems. And this is a good side effect, but on the other side also the hackers get more clever and clever. So this can also...
So there's a nice spiral there.
Yeah.
So everything gets better. People get more intelligent and systems get more secure.
I'm not sure they get more intelligent, but maybe
we hope
better trained.
Yeah. And we have done, and a lot of people have done that for years and years. This is also called jailbreaks. We know that from smartphones, from iOS devices, just getting root access on those devices. And there were many of them. For iOS, you find jailbreaks for nearly every version, but also for real gaming consoles, like for the Wii. There was a buffer overflow in a game, The Legend of Zelda Twilight Princess, which was called the Twilight Hack, and it allowed to run anything on the Wii. We had a similar thing on the PlayStation 2 with a buffer overflow in the BIOS. On the PlayStation 3, where we had a heap overflow. On the Xbox, we had a buffer overflow in a save game. There was this James Bond game, and you could load a save game you downloaded from the internet, and suddenly, when you loaded the game, it didn't play James Bond, but opened something else. Really cool. Buffer overflow, run arbitrary code. On the PlayStation Portable, this was also a hack many times. We had first overflows with images. You downloaded an image, corrupted image, which allowed to execute arbitrary games. And again, a save game. There was one game called Luminous that had a bug in the save game loading, and if you had this game, loaded a manipulated save game, you could run any software. And apparently many people did that, as you can see from the sales image here from Amazon. So the sales increased by more than 13,000% after they discovered this bug there, and it was from place 700 something in the best video games up to place 6.
So you're talking a lot about buffer overflows here. So I thought, okay, maybe we should clarify what that is. So I looked up on DuckDuckGo what a buffer is, and this appears to be a buffer, an automobile buffer. And I thought maybe this is a buffer overflow then.
I don't know which search engine you're using and how you trained that, but that's not the buffer we are talking about.
You can Google that.
I'm not sure my Google does that. I'm not sure on which pages you are. But never mind. So when we are talking about a buffer, we are more talking about a chunk of memory that we have in our system. And this chunk of memory has some boundaries, it's defined by a start address and by a size, and it stores elements in memory. So every one of you have already programmed in low-level languages like C, C++, or also high-level languages. You know arrays and how to use them. And as a simple example, we have this buffer here, which can store up to 12 elements, and we just copy some letters into it. Basic buffer. And the problem now with the buffer overflow is that we have to check whether the amount of things we put into the buffer is actually smaller than or equal to the size of the buffer. So we have to check the bounds of the buffer. And if we don't do that, then we have an overflow there. And this can be quite problematic. Most commonly, if you have an array, as seen before, we just write more elements into it or iterate over it, access some index that's not available anymore. For example, here in a small C snippet, we have a buffer of 4 elements and then copy 6 elements into it. That's a buffer overflow. So that's what we're talking about, and not those weird stuff you found on the internet. And buffer overflows have quite a long history. So they were first documented in 1972 already. So that's way before all these trainers and sheets appeared. And 1988, they were first exploited.
So wait a moment, you're telling me that they found this in 1972 and it took them 16 years to exploit this?
Exactly, yeah.
Wow.
Took quite some time because no one reads books. It was documented in a book.
Yeah, I can understand that.
So it took them quite some time to actually exploit that. Was the first internet war. And the time between exploiting it first and then documenting it took again quite a bit. So that was the first time in 1996 where this was actually documented in a real publication that was then on the internet, not only as a book.
Takes some time to write it down, right?
Well, writing is hard, you know that. But from that, it got quite fast. So we had a lot of tutorials and buffer overflows. It was named the bug of the decade. It was the most exploited bug. It was found everywhere. Then experts said the next new wave will be heap overflows. Again, a buffer overflow, a type of buffer overflow. And we've seen that it was used a lot in exploits to exploit real-world code out there. And then finally, in 2003, to get back to the connection with video games, it was exploited in the Xbox game, the James Bond game, to run unlicensed software. So we can do something useful with that.
If you look at the CWE class of buffer errors, buffer overflows and other errors in this field, you see that we had a steep increase in the early 2000s or around the mid of the 2000s. And then stack buffer overflows became less of a problem because compilers got better and better. More modern compilers have already countermeasures integrated into them, but heap overflows still are a problem today.
Yes, and if we have such, we keep stack overflows because they were mostly exploited. If we look at them, we have this buffer and then it overflows. And so that sounds maybe bad, like something is spilling around. But what is actually happening then? What is next to such a buffer if we overflow it? There are some interesting things next to it. We have other variables, other buffers, we have function parameters, we have saved return addresses, all that juicy stuff that should not be manipulated.
And that's really bad because now the attacker controls the input that is stored into the buffer and can override all these variables with attacker-controlled values.
Yes, and then the attacker controls a lot of stuff in our program.
That sounds really bad, but how complicated is this in practice? Can you show us an example?
Sure, we can do again a really small snippet here. Just simple C code.
Yeah, I think I would find it like that on Stack Overflow.
I guess, yes. And you just enter your name as an argument to the program, and it copies the name to the buffer, and then it prints hello and your name. Really simple.
Sounds really plausible.
First semester programming, everyone does it like that. And
I would do it like that, right?
Yeah, and it works. So if you run it, it works. So I run it and say hello students, and it says hello students. Great. Works. And then I run it with hello, a lot of A's, and it says hello, a lot of A's, and then it crashes.
Why does it say 41414141 here? That sounds...
That's a weird number, right?
That's a very weird number.
Do you know this number?
I don't know this number.
It's not your credit card PIN?
No, it's not my...
Okay. Nice try. This is actually the hexadecimal interpretation of the letter A. So it appears that the program wanted to continue at location A. Really weird, right? So what happened there?
If we go through the code step by step, this is always a good idea when we want to debug something, then we just start with the first line here, and we check the length of the arguments and then call this print name function. So what do? We push the instruction pointer where we will return to onto the stack, and then we push the base pointer onto the stack, and then we make some room for the local variables, 16 bytes. And then we do the string copy and copy these bytes that we got from this argument here into this name variable. Ah, that's what you meant. Okay, it's the representation of the characters, and now I have 414141, for instance, in my instruction pointer. And as I return from this function, the processor will pop this value from the stack and return to it.
Which is wrong.
Yeah, it shouldn't do that. But does it have any practical relevance?
As we have seen, we can jump any address we want to jump to. Not only the AAA address, but I can write anything there as an attacker and just go there. And if I can jump to any location, I can jump to any code that's already there and execute that code and jump over stuff I maybe don't want to execute. So I can basically change the control flow and run everything, have full control in this application there.
Maybe we should look at a real program, right? Maybe a game, yes. And my absolute favorite game, of course, is Pokemon. Released in 1998 or 1999, and it is among the best games of all times, that's known. And it's very sad that they never produced any sequel to this game. By now it has been completely reverse engineered, so you can check out the C code, the reverse engineered C code, and change in the game whatever you like.
So I could do a sequel, like a Pokemon
You could.
Yellow.
You could not.
Oh.
That's not possible. Okay, but in the code there are many bugs, and one of the bugs is in the cable club. Let's talk about this cable club. This was really nice. Back when we had the Game Boys, we were exchanging Pokemon over this cable club. So we have a link cable that connects two Game Boys, and then you can exchange one Pokemon with a friend, and you get theirs, and that's really nice.
Assuming you have friends.
And there was this very nice trick. You could pull out the cable during the exchange and you would clone Pokemon by doing that. So both have the same Pokemon then, or the one person keeps theirs and the other gets a copy. And this is really nice, and this is sort of a hack, right? It's a hack.
It's a hack.
But there's a related idea. Maybe we could do something like modify Pokemons during exchange. Okay.
So you send me your, I don't know,
Magikarp, and you get a Mew.
Get a Mew.
We could do something like that.
Nice.
Yes. But maybe we can do something more interesting, because this is like, okay, you're cheating and getting a few new Pokemon.
That's like the script kiddie cheat.
Yes.
Yeah. Changing your value in there.
Maybe we can do something more interesting, something more devastating.
Yeah, maybe that would be really cool.
Yes.
We wouldn't do that.
Yes, of course not.
So if I send you the list of my Pokemons, it has to be terminated. I don't always have my 6 Pokemons there. So it's terminated with a special character when it's the end of the list. So you know that no more Pokemons are coming. And what happens now if we do not terminate this list? You think it has a fallback like, okay, at maximum it's 6 Pokemons there, so we stop after 6. No, it does not. It just overflows. It just continues copying on and on and on. It's like the original code from the Pokemon game. It just copies stuff into the buffer until it finds the terminating character. So if there's non-terminating character, it goes on and on and on. And we see I have a lot of Mews suddenly, and I get more and more of them, and then the game crashes. We have a buffer overflow here. And the Pokemon names go into the stack, and then it jumps at some address which is Mew, and there's nothing. But maybe we can create a certain set of Pokemons that, when transferred, do something much cooler. So I tried to do that. I have a Pokemon here, an emulator. So that we can do it in a live demo.
You have to set it on top.
Yay, Pokemon. Okay, and yeah, intro.
So now you have to start a new game and all the stuff.
we
So
have to play
this will
it
take a
for-
while.
Yes, the remainder of the talk, right?
Ah, yeah.
No, I have a save game.
Okay.
Directly the cable Klug.
Ah, but now you need the link cable and a second Game Boy,
Yes.
right?
Yes. Do you have one?
I have my laptop
Anyone
here.
have
If that.
Like Pokemon Red on a Game Boy? No.
Okay, these emulators can now do that. They simulate this link.
And then we do one. Then we have our hack here.
Wait a moment, that is not a Game Boy.
That's my Game Boy. That's a much more powerful Game Boy called Python. It's the new version.
Okay.
So, okay, I can now run that. And if I go to I talk to the nice lady there, welcome to the Cable Club. It says, Cable Club started. Please apply, okay. The save again, fine. Go to the trade center. Okay, nice. And now I want to exchange Pokemon. And now it's hacking, and it's the progress bar. Yay! And that's not a Pokemon. That says, hello game, they've tasted Graz here in the Pokemon game. So I can run any code I want inside Pokemon. And people actually did that to create a virus. Yeah, really mean. That destroyed everything you had. And if you connected your link cable to a different Game Boy Pokemon, it also destroyed the other game. Really mean. We don't do that. We just do an animation here. So we can see we can actually do that in a real game with this buffer overflow. And now the presentations.
Yeah. Okay.
And we can basically run anything on our Game Boy and even load more games, more data. It works on a real Game Boy as well. It's not a bug in the emulator, it's actually a bug in the game. And we can use that to run any game we want.
Okay, so this is only a simple buffer overflow, but this simple buffer overflow allows us to run arbitrary code. And this is quite devastating here because now we have this homebrew, as you called it, right? Homebrew on the Game Boy, and we could run anything on the system, run viruses, run pirated games. So this is really bad. And the problem here is, of course, that we subverted the security completely, but it was actually non-existing. This was never in the threat model that they had back then. They were not thinking that anyone would run their own Game Boy cartridges and spread viruses over that. That was just outside of the threat model. What can we do against it? So there are several countermeasures that we nowadays have that also back then they didn't really have. For instance, binary hardening.
That's quite new. So nowadays we have compilers, compiler flags, code analysis tools that would really shout at us and like, don't do that, don't do that. It's really bad what you're doing.
So you could have had a secure version of Pokemon, which is not hackable, right?
You could have had that.
Okay.
If Pokemon appeared like 20 years later.
But the problem then again is also, would it have still fitted on the same cartridge? Because with security you also have overheads, and that's often the binary size that increases. You could use existing libraries. When we were in Qualcomm, I think there was 1.5 years, at Qualcomm in San Diego, 1.5 years ago, we heard a talk from people from Uber, and they said, we don't trust any libraries, we write everything on our own, so we don't even use the libc. Okay.
Yeah, don't do that, really. The libraries we have, they're really well tested, used by a lot of people, analyzed by a lot of people, they've been tried to be hacked by a lot of people, so you get a quite good security from using existing widespread libraries. If you do everything on your own, yeah, if you're a really good programmer, still don't do it.
And then what we also heard in the previous talk, don't trust user input. Users are always the pure evil, never trust them.
Yeah, everything the user inputs can be abused by the user, so we have to sanitize all the stuff. There are libraries that deal with user input, they do the hard job for you, and you get the filtered, nice input out from the evil user input.
Yes, and finally, of course, you need to test. So you need to test a lot, you need automated tests. Today we use, many people use unit tests, and that's a good development since the 80s. So we came a long way, and now we are in a much better situation, but still we are in the start of this scenario where we need security for games. Yes. So what do we have to keep in mind? As I said, user input is evil. Whitelisting is more secure than blacklisting. That's something we often observe. If you blacklist something, usually you forget about one corner case.
And some smart user finds some way around your blacklist.
Or a really dumb user can also have
Yeah.
Yes. Input can also be indirect. That's something we recently showed, that we can mount this Spectre attack over the network, and there we only send network packets. Network packets are user input as well. They just come from a different cable connection, sort of.
Like the link cable.
Yes.
Or files, as in safe games.
That's all user input.
Yeah, so it's a good thing to remind yourself of. You shouldn't trust, never. Always verify the stuff. That's really important. So that was the first part of piracy. And we have more. So we talked before about cheating. And if you talk about cheating, I guess everyone knows what cheating is.
I don't know what cheating is.
Not for exams, but maybe in games. So you act in a way that gives you an unfair advantage over all the other players.
Who would do that? Right?
No one is doing that. Not in games, they're not fun anymore.
Right.
So cheating was really always part of video games, because it was put there by developers. Developers are lazy, and you've learned you have to test a lot. So they implemented cheat codes to ease their testing, because they can just jump to a certain point in the game, or give them certain advantages to make the mission easier for them. And then we had cheat programs, trainers. They appeared in 1981, and there on the right is a nice advertisement from 1983. The Great Escape Utility for Castle Wolfenstein, and they implemented a lot of hacks there and also improved the game. And you could buy that for your Apple computer and run this game, and it modified the original game to give you advantages and more stuff to do in the game. So it's really old. It's from 1983 already. And yeah, it modified the game.
So you're talking about things that are in memory, right? And everything is stored in memory. The health, money, stats, anything that defines the game is held in memory. And trainers basically can just modify these values, and by modifying those values you get some advantage. And this is maybe not a problem, but the problem comes when you can do this to cheat in multiplayer or in online games, right? There are different formats for storing numbers. We have to talk a bit about numbers, because in computer games they often store things in numbers, like the amount of money you have.
That's a number.
And there are different formats. We have binary for unsigned integers or positive numbers. We have the 2's complement for signed integers. But we also have these, they are a bit more ugly, but you will talk about that in a second. The floating point numbers, where you store sign bit and magnitude.
So that already sounds like quite a lot of stuff that we have. And if you look at that, it also looks a bit complicated at first glance. So many of you might know that. So if we talk about unsigned integers, then we just have a few bits in memory. And they are just interpreted as this unsigned integer. The bits are for the powers of 2, say whether this power of 2 is used or not used. This is complicated formula, complicated looking formula out there. It's not that complicated. So basically with an unsigned number, we have a fixed number of bits, and then we can represent values from 0 to 2 to the power of the number of bits that we have. And then we have other subtle bugs we're not talking about today, like integer overflows. What happens when you're already at the maximum amount of money, and then you get one more money, and you suddenly have 0 money, which is really bad. Also the other way around, you have 0 money, you lose 1 money, you have the maximum amount of money. We're not talking about that, but that also happens quite often in video games. For signed integers, we would use that for money if you could get negative money. And we have the signed integers, which can also represent negative numbers. And then we just use one bit and a bit of different encoding to store this number. But again, it's the same principle. We have a certain number of bits that encodes this signed integer.
But that's quite bad. If I now overflow, I have a lot of money that I owe to someone, right?
Yeah, it's great. You could also exploit that in certain games. And the most complicated looking integers are floating points. We also use them quite often to have some non-integer values. Looks really complicated with math and stuff, but it's actually not that hard. So we can really do that by hand. What the formula showed before, for example, we have this number 3.3125, and we can convert that to binary, and then we just have to normalize it in a way that it only has one number in front of the decimal dot, and then we have a sign bit that's either it's positive or negative. Here it's positive, a 0, with an exponent that we can calculate. We encode the fraction, again, as a number, and then we have a resulting, weird looking, again, binary beta. And we again have a fixed number of bits that represent this floating point number. And we can test that it's actually correct, what you have on the slides here. So it's still just a bit better in memory, right?
Okay.
So we can also search for that. If we know that every integer, every floating point number has a fixed format, a pattern in memory, you can look for that in memory.
But how would you do that? You can't just look in the memory of this computer game.
Actually, you can. There are dedicated tools for exactly this purpose, to look for patterns in other programs. It's like an ArcMoney or Cheat Engine. They're quite old already, but they're still developed. And they allow to really read the memory of other programs. And that works for many games. And it's really easy, because you see a value in the game, search for it, and modify it. And a lot of people can do that. It's
But
not hard, right?
I mean, you're searching for some binary string here. What if the wrong value matches? You can break everything with
You
that, right?
could break everything,
Okay.
yes. But then you repeat it a few times, and it's really easy. And I tried that on a game. I don't know, maybe some of you have noticed games called Candy Crush, and some game apparently a lot of people play, and you have to do some moves, and it's a complicated game. I didn't get it, but it has moves, and you have only a certain number of moves. If you're out of moves, you're game over. And so I said, like, oh, I have no idea what I'm doing, I want more moves. So I used this cheat engine, searched for the number of remaining moves, 48, there's a match, and then I changed it to 200. And I had 200 moves left in the game. Really easy. So this is 2018, so that worked like 20 years ago, and it still works. And it's really easy to pull off as a normal user.
As I said before, don't trust user data. The user is the pure evil and wants to trick you into something. So what you should do is you should store important values on the server. Ideally, just do the entire computation on the server and only compute it as well on the client, but do not trust or use those values later on. Yes. Use checksums for data, or even better, encrypt data. You can encrypt data and make sure that the user can't easily decrypt it. Of course, if you encrypt it, you need to have the key somewhere, but you can use something with a remote key where you only get a few bytes decrypted all the time. And even a simple XOR is already a lot harder to hack for casual homebrewers.
Let's call it like that. Yes, so Candy Crush was a bad example. They don't really have security there. A good example is this game GTA 4. They really thought about security, and they really started with security from the start of the design process. They didn't try to add security on top of everything, but they incorporated it in the design process.
So they did everything right.
They did everything right.
Okay.
As right as you can do it.
Okay.
So they actually split the game into two different parts, in a protected and unprotected part. And this unprotected part has nothing critical in it. It just has user input, draws to the screen, and it has to be fast. And then you have the protected part for all the important stuff like your value, your money, your health, your weapons, your missions, and stuff like that. This has to be secure. You don't want anyone to just take the cheat engine, look for the value, change it, profit. Nice. So they wanted to make that really secure and make it hard to cheat. So they encrypted the values, as you said. And they even went a step farther. They also made the memory read-only. So they set the memory to not writable, so the cheat engine couldn't manipulate the values there. Really nice. Of course, they had to manipulate the values themselves, so they had certain functions for that they could set it to writable for a short amount of time, change it, set it back. And so that you cannot simply call these functions, they also required some secrets and key to be called, and this also had to be reverse engineered from the game. It's a lot of work, so the hobby homebrewer has no chance in that. It takes quite some team and a lot of time to actually break that security.
So all of this is still in memory, right? We're still talking about in-memory values. But are there also things that are connected to the game that are not stored in memory, like save games? There the values are not in memory but in files, right? And save games store important values like money, health, etc.
All the same as the memory.
Yes. So if I can edit something there, I get the same advantage, right? So it's very similar, but I even have a small file probably where I can search for this value. Might be easier.
Yes, so again, back in time, quite far back in time, so I guess it was even before some of you were born. That was SimCity in 1993. So it's
You're now talking about a bug in a software from 1993.
exactly.
That's so university, right?
Yeah, we're not that fast. Let's talk about, yes, SimCity. A really cool game. And there was a book for that, so if you were stuck, needed some help, there was this walkthrough, this guide that gave you some hints, like, oh, what?
Oh, I know that. Those are Norton utilities. I used them back in the 90s.
Yes, this is the hexadecimal view of the SimCity save game.
Oh.
So it's like, okay, why would I need that in any manual? And it's like, okay, we're talking about money here.
Oh, this number looks very interesting, right?
Yes, like next you change the 00 to a 7F, and then it adds a lot of money to your city. And then it makes it a lot easier, of course, yeah? So if you have troubles winning, then you just edit this one value there. And it's a lot easier then.
But this is like in 1993. It would not work today, right? Today we are much...
still works. So I have to sim... Oh, really?
No.
This is the 2014 version of SimCity. And I played that on my tablet, and if you start it, you have like no money, and no money is boring. So you open up your file manager, and you replace the save game there. And you don't even need root access for that. And then you again start the game. Oh, and then you have a lot of money. Then it's much more fun to play, right? So yeah, this still works like 21 years later.
Okay.
So great. It's really similar to memory hacking. We can use the same principles, search for the same patterns in the safe game, and we have similar countermeasures, of course. We can also encrypt the stuff, have checksums, store everything on the server, as we've heard in the last talk, so that nothing is actually stored on a client. If it's not stored on a client computer, it can't be manipulated easily.
You know what I haven't brought in, so I talked a lot about user input already, but there's also another aspect here. It's not just the input, like save games, like the stuff sent over network, like the things I type. It's also just the entire environment, right? Where I run the game.
So your operating system.
Yes. Basically, the user can modify anything. The user can modify the binary, right? They can modify whatever they like, files, network packets that are sent or received from the game. You can.
But you know what? They signed this EULA that they are not allowed to do that, so it's fine, right?
Yes.
Okay, so.
They can also. I just.
But they still do that, right?
No one would do that, of course.
Okay.
They can also change functions. You can hook and preload functions and change what they do.
There's even a framework from Microsoft for that. It's not designed for cheating in games, but of course you can use that. It's called detours, and it allows to manipulate every function in your Windows operating system and replace it with your own function, or just change some arguments in the function and filters on functions. And it's really, really cool. For example, if you think you have your game and it connects to an internet service and it checks whether it's pirated or not, and then you redirect this function to your own server. Similar to the things we heard in the last talk. So this is even an official framework that you can use on Windows. Do you know anything on Linux?
On Linux, there's LD preload. Also very nice. It's a feature of the loader on Linux. And basically you can pass ELF shared object files to it. And the loader will load those ELF shared object files before loading the binary. And yeah, then you can replace functions that are implemented in the shared object file and also in the binary. And it will use the ones from the shared object file instead. So you can override functions.
Great, so let's do a fun example with that. Again, first with a bit of a code snippet.
Yeah, that's something you could find on Stack Overflow, I guess.
Yeah, again, we have our ultra secret password in our application, and we copy that to a buffer. It's not a buffer overflow this time, promise. And then we compare, and then we say, okay, if we are a root user here, then we output this super secret password, otherwise we say no, only root can get that. So it sounds fine. It's like something you find on Stack Overflow. If you run that, it's also fine, only root can get the password. Then we do this ND preload trick. And so we want to override the string copy function, and let the string copy function output what we actually copied, and then copy it. And we can compile that as a small object, and then use the ND preload for our own string copy function, and it's replaced in this program. And then we see, oh, we copied this ultra secret password here, and then it says, oh.
Yeah, but you need to be sudo to do that, or root, right?
No, that's the nice thing. Everyone can do that. Great, it's a really nice tool. And we can again use that for cheating. If we, for example, so who knows Tetris? Everyone, right?
Tetris, yeah.
Great, sure. It is a complicated game. It has different shapes falling down, and
No, I meant a different Tetris.
What do you mean?
No, let's talk about that later.
You have different shapes coming down, and then you have to connect them, and this is really hard. And my favorite tile in Tetris is just this 4x1 block, because it makes it a lot easier. And so, let's see if this works again. So I found a Tetris game on the command line, so I can play it during work.
I think you're not allowed to do that, right? Playing during work.
And then I can play that, and yeah, different shapes, and so complicated, I don't know. I don't know. I'm too bad at this game. So I decided it would be a lot easier if I only have this red tile here. So what I did is I overrode the random function. The super secure random function. This is the best random function because it's not random anymore. And if I use this one, so, and then I can compile that and preload it, no random. And if I then play Tetris, then something didn't work.
Cannot be preloaded.
Yep. Because it's a bit hard.
Now you need pseudo, right?
No, I don't need pseudo.
Oh, we'll see.
It's a bit hard with the display here. Okay. Well,
They can't see when you type
I
pseudo
can't see
there,
what I type.
right?
That's a bit of a problem here. Where am I? Yeah. Okay. Here. And then I do the LD preload and
put pseudo in front of it, right?
and like this. And if I play it now,
Oh.
that looks much easier, right? Oh, I can even get a combo there. That's great. It's like now Tetris is fun, right? Okay, so I can also do that with preloading, and I can do it for every game and replace every like random function or stuff I really don't want to have in the game, and replace it with my own function.
Yeah. Okay. Yeah. So this might be okay if you're playing a single-player game, right? If you want to take a shortcut. I always do that when so I don't read books very often, but when I read a book, I first check the last few pages whether I like the ending, right? And maybe this is also fine here.
Yeah, cheat until the end and say, oh, it would have been a nice game.
Yeah, and
So
then I
let's
maybe start playing. Yeah. But it's problematic for multiplayer games, right? Because if you can cheat there, we all know that from the, or maybe not, from the late 90s, where in all multiplayer games you could cheat, and then there came these anti-cheat programs that you had to run simultaneously. Gamers get frustrated if you can cheat, but also it's problematic if in-game purchases are cheated, or if you have certain features that are restricted or that depend on a game purchase. For instance, for Pokemon Go, there was this situation where you could change the time and by that have a longer advantage from some of the items that you could buy. So you would cheat yourself more time, and you should usually pay for that, right? So it could be a potential monetary loss.
Yes, so we like to prevent cheating in games, but that's nearly impossible. As we have seen, we have so many tools, users have a lot of time, and we only have ways to make it really, really a lot harder. We can add plausibility checks, like is it plausible that we always have the same tile in Tetris? Seem to do odd. Use cryptography, but that just buys us a bit of time. It's not a perfect solution, we don't have that.
That's why we have those anti-cheat tools, right? The
Yes.
testing is sometimes much easier.
Yes, if you run the server and see this like really weird data coming from the user, it's easy to detect that and then just ban the user in multiplayer games. So why do we do that? Some people do that for fun. Some do that for profit. Privacy is usually something where you can get a lot of money with. Also, cheating is something you can make money off that. What would I add? So, first we need to hack a game if you want to make money. And then we profit. We just need the second phase. And
Do you have an idea for that?
yeah, I have an idea. Fraud. Fraud is nice. No, it's not nice, but it's a good way to make money. And you can.
You're not recommending.
I'm not recommending fraud.
Okay.
You can get financial stuff with that in a really easy way. Because if you look at the game industry, there's a lot of money in the game industry. He has like billions of dollars in there, and could be easy to get some of that.
Yeah, and yeah, gamers pay for online games or in online games, but also there are things that are not directly money, but that you can make to money. User information, for instance. User information is stored on servers, and that can be quite valuable. Personal information, or even credit card data. That's also very nice.
If you think of the PlayStation Network data breach in 2011, there were 77 million user accounts stored on their servers and 12.3 million credit card informations. So it's like a lot. You can get a lot of money with that. And there was no evidence that this credit card data was actually stolen, it was only the user data. But weirdly enough, there were still some reports of fraud. So people using the credit card just for the PlayStation Network still had weird transactions on them.
Yeah,
so
that shouldn't happen if
that
the
shouldn't
data was
happen
not
usually.
stolen. So
Yeah, credit card data is nice, but not the only target. This personal info can be made to money, right?
on the black market. Yeah. So I've looked up something here. Brazilian underground.
You went on the black market,
I had a friend who
did research.
yes. And it turns out that some data sets are much more valuable than others. For instance, the credit card credentials, they are quite cheap, right? You don't get a lot of money for that because credit cards, you can't get much money out of the account before the credit card company blocks it.
And they have good fraud detection.
Yes. But something that turns out to be very valuable, landline phone numbers. Who still has a landline phone number? Maybe because there are so few, they are so expensive. Right? The market sets the price.
So we also need to secure the backend, where all this data is stored. And again, we have this backend receiving user input, this pure evil user input. And often that's not even obvious. Like you have a high score, you have a chat, you have some inventory, and the user changes values in there. Changes his name or stuff like that. And it gets sent to the backend server.
Yeah. Next problem, as I already mentioned today, Stack Overflow a few times. Code that you find online is often without security. And that's a huge problem. For instance, if you directly build database queries, you can have SQL injections. The user can maybe also exfiltrate data if the user controls the query.
Imagine you have this high score list, and some of your players is called Robert Drop Table Students or Drop Table Scores, or
That's bad.
select stuff from credit card info.
Yeah.
And suddenly the user gets into the score, maybe by cheating even. And
Yeah, but why would people call their children like that? Because they are pure evil, as I
Exactly.
said. Yeah.
Never trust users and their inputs. Names are inputs as well.
Yes.
So we need to really secure our backend to protect not only the infrastructure of the gaming company, but also the gamers. We don't want to lose the data of our gamers. They also get a bit upset by that usually. And we have a lot of private data, depending on the games, and this is quite valuable as we have seen.
Yeah. Did you really put this on the slide? I'm not sure we should advertise that. So, hacking in games sounds like fun, right? And it can be fun. Apparently you did that for fun. And also that you have a side effect, you learn something about security. That's why many companies today have sort of the blue team and the red team, where they sort of have an offensive and a defensive team, where one team tries to find security loopholes and the other tries to approach it from a more defensive side. So where do we start? Right? When I want to hack games, where do I start?
Yeah, don't hack just any game. There's even something that we can use for that. It's called pawn adventures. You misheard that, yeah? No, it's not. It's like that.
Oh, okay. What does it stand for?
It's from be owned pawn.
Oh, okay.
Yeah, so it's not
Okay.
with the. It's
Okay.
for people even that are not 18
So
years.
it's a Pony Island, right?
Yeah, it's a pun.
I see.
And this is a game, an actual game. It's an MMORPG in 3D, and it's made intentionally vulnerable. So it's a learning platform for game developers. They actually did it just for that, to make game developers understand how the design and the programming flaws in games affect their games, and how vulnerabilities are created in the development process of games. And this game has multiple quests in it, like any other game. You can actually play that, but some of the quests can only be solved when you hack the game. So you really need game hacking there. And a lot of techniques, so it's not always the same thing. They have a lot of vulnerabilities in there, and some of the stuff, like the preloading, we've covered in this talk, but others we have not, because there are so many techniques out in the wild. For example, you can intercept the network and then manipulate the network packages to build a teleporter. And you can jump wherever you want to. Or you reverse engineer the game, you find some hidden elements in there that you need for a quest. You can manipulate some of the functions to jump higher, run faster, all that stuff. So there's many techniques and things in there that you can actually hack.
So they did intentionally do everything wrong, right?
Yes.
Okay.
It's like worst practice.
Okay.
And yeah, we talked about a few things in the talk, but there's much more. So where do we start? There's a really nice GitHub repository. It's the ultimate game hacking resource, and it talks about a lot of these things, even more than we covered in this talk. It's a good starting point. So we all know playing games. What's more challenging is programming games. Then we have the next level of hacking a game. And then we have programming a secure game with all the techniques that we learned from actually hacking a game. So that should be something you want to do as a game developer, to actually hack games first, to see all the vulnerabilities, and then make secure games in the end.
Okay, and with that we get to the conclusion. Security in game design is often neglected, and the reason is just because it didn't matter so far, right? Because when Pokemon came out, it didn't matter to have security there. But today the world has changed. Today we are in a connected world. We have lots of private data. No one had their credit card data stored on their Game Boy, right?
Yeah.
Yeah.
They didn't even have credit cards.
You could have done that. You could have used the names for that, right? But seriously, no one did that. So you don't need any security there. But today this has changed. Our personal data and our financial information is always connected to the games that we play, and that requires that we need to think about security. Old hacking techniques, that's something that is really a bit disappointing also.
Yeah.
That we can just use those old hacking techniques on many games. Also, as we have seen in the previous talk, many of the ideas mentioned have been discussed in the security community years ago, and they are still relevant today because we are disconnected communities to some extent, and that leads to problems. Vulnerabilities can cost money. You can also make a lot of money out of them, so you want to get rid of them as a developer. And finally, as also said in the previous talk, you cannot really retrofit security mechanisms. You have to design them into the system from the start.
So what are the takeaways of the talk? Never ever trust the user input. The user is evil. The user input is evil. Everything that comes from the user is evil. Never trust the user. It's really easy to hack games. So even nowadays, it's not that hard if you play a bit around. And as Daniel said before, it should be part of your design process to think of the security of your game and also your gamers. And small implementation details there already make a difference and can make it a lot harder so that the homebrew kiddie cannot hack your game anymore.
And with that, we would like to thank you.
Thank you so much. This was a wonderful show, actually, almost. Do we have questions in the audience? We have time for 1 or 2 questions, I guess, and then we're going to the break. I never already saw something on Twitch. Let's see. Yes, Thomas. You were just enter, I know better.
Sorry, I missed some of your talk. I was cooling down.
No problem. You probably knew most of it.
Yeah, thank you. If there was one thing that you could change about game development, if there was one thing that you could impart to game developers about security, what would that be?
That's a good question. So, if you just follow the best practices we have in other software engineering disciplines when writing web applications, operating systems, drivers, and stuff like that, if we have these best practices, I think already many bugs weren't there.
Yeah. Also, with more modern tools, we get rid of many bugs. We have more modern compilers today. So many of the bugs that were exploitable like 2 decades ago would not be exploitable today anymore because of these automated countermeasures. But it is something that we also observe in completely unrelated fields. The processor manufacturers, they had their security problems earlier this year, and they were in a situation where they said, okay, our processor is an isolated environment, it runs on its own. I don't need to care for any security like user input. I don't care about user input because I'm running on an isolated machine. And turns out they also have to adapt their view and take security into account. And I think that's the main problem we have here, that we have areas where security was not relevant before, and suddenly everyone is like, whoa, why did no one ever think about security? We are screwed.
It's also something you had in your talk with threat modeling. So if you have your threat model wrong, then you have problems there.
Yeah.
Do we have more questions from the audience? There was one comment or question in the Twitch stream about what is your take on frameworks like Steamworks? Is there a way to still make it more secure even though you're relying on a framework?
There is this problem that with the framework you also integrate all the bugs of the framework, but generally I don't think the way Uber did it was a good decision. So just saying I don't trust any libraries and write everything from scratch, I think it would introduce a much higher number of bugs this way, and probably more trivial bugs that are easier to exploit. So if you have something like a bug in a library that existed for a long time, it's probably a bug that already needs like a long chain of steps until you get to exploit it. And if you write everything on your own, you probably have a much shorter chain of steps that you need to take to exploit it.
So it's a good way to use frameworks,
yeah.
But you should not be in this false sense of security that if I use my framework, I'm fine, nothing can happen. So you still have to follow the best practices then.
Yeah.
More questions from the audience? Or on Twitch? No, this was a comment. I was just reading, sorry. Okay, thank you so much. This was really fantastic and such an important topic. And thanks, they just prepared this talk for you guys, even though they're in the moment all over the world. And so thanks a lot for coming here and presenting here. From our side, we have some good news for you now. I'm giving the mic to Stefan.
Hello.
Danke.
Now, yeah, we have a break. Take a break, have some coffee, we got some snacks, and most important, now we got beer. Cold beer. So, see you at the fridge.